if I had a plus b to the 0, that equals 1. A plus b to the first, that's just going to be 1a plus 1b. And I'm going to write the ones there because it's going to help us in the future. If I had a plus b squared, I would need to use the box. A, B, so a squared, a, B, and b squared. That ends up being a squared plus 2ab plus b squared. Right? What if I had a plus b to the third? I would take, really I could just do a plus b squared and multiply that by a plus b. So this is this. So if I draw a box and I put ab on one side and a squared plus 2ab plus b squared, that would give me a to the third plus 2a squared b plus ab squared, and then a squared b plus 2ab squared plus b to the third. And when I write that out, I get a to the third plus, how many a squared b's do I have? Would be these two. So 2a squared, wait, is it 3? Sorry. 3a squared b plus, if you look at those two boxes, I would end up with 3ab squareds plus b to the third. Now I'm flying through this. You're not going to have to do what I'm doing, which I'm just going fast to build it up. What if I had a plus b to the fourth? I could do this times a plus b, but I don't want to. Tiana has a different idea. Why don't I just do this times itself? So if I change this to a 3 by 3 box, a squared b, or 2ab, oh my goodness, and then b squared. A to the fourth plus 2a to the third b plus a squared b squared, and then 2a to the third b plus 4a squared b squared plus 2ab to the third. This one would be a squared b squared, and then plus 4ab to the third. Not 4, 2. 2ab to the third, and then b to the fourth. When I write this out, I get a to the fourth plus 4a to the third b plus 4, 5, 6 a squared b squared plus 4ab to the third plus b to the fourth. Now I'm kind of building a triangle here. Do you notice any patterns? So if I go across the row, Tiana's looking at the exponents. What do you notice about the exponents? So the b's get bigger as we go to the right, and the a's get smaller. So without looking at the coefficients, what would the exponents be on the next line? What would the first one be? A to the fifth plus something a 4b plus something a to the third b squared plus something a squared b to the third plus something a b to the fourth plus b to the fifth. So the pattern for the exponents is really easy. We start with whatever number you start with, like 5, 5, 4, 3, 2, 1, 0, and then it would also be 0, 1, 2, 3, 4, 5. What about the coefficients? Do you see a pattern? So this row right here is made up of nothing but ones. So 1, 1, 1, 1. And then what about the next row? 1, 2, 3, 4. So what's going to go here? 5. And if there's a 5 there, well, if we have a 5 here, the next one down would be 6. But what else? What else would the 5 be? On the other side, this would be a 5. It is. It's Pascal's triangle. And in Pascal's triangle, we can take these two and add them together and get the one below. So those two add to be 3. These two add to be 6. So these two would add to be 10. And these two would add to be 10. So the exponents are pretty easy to figure out. And the numbers in front of the exponents are also pretty easy to figure out. You just go to Pascal's triangle, and there's one on the wall, and there's one in your book. And you just go to the appropriate row, and then you put those numbers in place, and then you put your variables and exponents in line. Okay? But what if instead of plus b, it was minus b? Not all of them, right? It ends up being every other one is negative, because the first ones will always be positive. So this would change to a negative. And on the next row, it would be plus, minus, plus. And the next row would be plus, minus, plus, minus. So the first one's positive, and then you go negative, positive, negative, positive, negative, positive. So down here, this would change to a negative. That one stays the same. This one changes to a negative. That one stays the same. And this one changes to a negative. Does that make sense? Okay. So how do we use Pascal's triangle to do binomial expansions? So we went all the way to 41, correct? Okay. Let's say I had 3x plus 4. Let's do 5. 3x plus 5 to the 4th. Okay. A lot of it I can figure out in terms of A's and B's. So let's write out the AB answer. Well, I'll write out the AB answer, and then we'll plug in the numbers. Okay. So we go down to row 4 of Pascal's triangle. What does it tell us? 1, 4, 6, 4, 1. So I'm going to have 1, 4, 6, 4, 1. Now, it would be 1a to the 4th, b to the 0. We just leave the b off. Plus 4a to the 3rd, b1, plus 6 a squared b squared plus 4a b to the 3rd plus b1b to the 4th. Does everybody understand that? And we skip all the way to the end. Right? We don't have to multiply them out and then multiply again and then multiply again and then multiply again. Now the only thing we have to do is substitute. This is a and this is b. Right? So 1 times 3x to the 4th plus 4 times 3x to the 3rd times 5 to the 1st plus 6 3x squared times 5 squared plus 4 times 3x times 5 to the 3rd plus 1 times 5 to the 3rd. Does that make sense? And then we just go through and simplify. So what is 3 to the 4th? 3 times 3 is 9, times 3, 27, times 3, 81. And one easy way to do that, this is how I remember it. 3 to the 4th is 81 because 9 times 9 is 81. That's how I remember 3 to the 4th. Okay? So I have 1 times 3 to the 4th times x to the 4th, which gives me 81x to the 4th. Does everybody understand that? Then I move on. What is 4 times 3 to the 3rd times 5? I don't know. Gonna need a calculator for that one. So 4 times 3 to the 3rd times 5. Oh, don't do that. 4 times 3 to the 3rd times 5. The coefficient is 540 plus 540. What about the variable? X to the 3rd. Does everybody understand how I did that? Okay, for the next one, I'm going to take 6 times 3 squared times 5 squared, and then the answer will have an x squared attached to it. So 6 times 3 squared times 5 squared is going to give me plus 1350 x squared plus 4 times 3 times 5 to the 3rd. What is 5 to the 3rd? 5 times 5 is 25, and if you have 5 quarters, that would be 125. So it's going to be 125 times 12. 125 times 12 is 1500x plus 1 times 5. Oh, I messed up. That should be a 4th. So 1 times 5 to the 4th is going to be 625. That is the product. We call this the binomial expansion. So this process I'm teaching you is the binomial theorem. If you have a plus b raised to the whatever power, you can use Pascal's triangle and the pattern of a to the 4th b, a to the 3rd plus b squared, or times b squared, and so on, and then you can skip straight to the answer. Okay, so let's try this. 2x minus 3y to the 5th. Write that down somewhere. What is our first step? Go to the triangle and pull out the coefficients. We go down to row 5. 1, 5, 10, 10, 5, 1. So we write those down. 1, 5, 10, 10, 5, 1. Now what? I would do your A's and your B's, just so you make sure that you get it right. You start with a to the 5th and no B's. So we just go down a to the 5th, a to the 4th, a to the 3rd, a squared, a, and no A's. And then no B's, b, b squared, b to the 3rd, b to the 4th, and b to the 5th. Everybody okay with that? Now what? Oh, hang on. I tricked you. I need to worry about negatives this time. First one is always positive. So plus, minus, plus, minus, plus, minus. And I would not plug those into your calculators. I would just remember that every other one is negative. Okay? So now I'm going to just plug this in for A and this in for B. So 1 times 2x to the 5th minus 5 times 2x to the 4th times 3y. No, well, that's the thing. I would leave the negatives out. If you put the negatives here, here, and here, then you don't need to worry about the 3 being negative. You could, and you'll notice what happens when I plug -3 into that one. It becomes positive. But there's such a chance for error, I wouldn't do that. I would leave your negatives out front and not put them inside the b's. Okay? So plus 10 times 2x to the third times b squared, which would be 3y squared, minus 10 times 2x squared times 3y to the third, plus 5 times 2x times 3y to the fourth times, or sorry, minus 3y to the fifth. Okay, you go through and calculate those, and I'll do my own calculations, and we'll see if we get the same answer. Yes. Right. It's 2 to the fourth and x to the fourth, which is why I put parentheses around the 2x. 16x to the fourth. But that 16 is also going to hit the 5 and the 3. So you do all of the numbers and then the variables. So this first one is just going to be 32x to the fifth. But the next one is 5 times 2 to the fourth times 3 times x to the fourth times y. Isn't that 2 to the fifth, 32? 5 times 2 to the fourth times 3 is 240. So minus 240 x to the fourth y. So it's, so 2x to the fourth is the same as 2 to the fourth x to the fourth. They're both underneath that exponent. So they both get a fourth power. Does that answer your question, Tiana? So for the next one, I would do 10 times 2 to the third times 3 squared, and then x to the third y squared. 10 times 2 to the third times 3 squared is 720. And then I know it's x to the third and y squared. Is that making sense? Okay. And the next one. I'm getting this. Okay. Is that what you guys got? Okay. And again, please leave the negatives out of the calculations. The reason why, if I were doing negative 4x to the sixth, my answer should be what sign? Positive or negative? Should be positive. So watch this. If I type in negative 4 to the sixth, it ended up giving me a negative number. Why is that? The calculator is following order of operations. We have a subtraction and we have an exponent. Which one's first according to order of operations? Exponent. So the calculator did the exponent and then did the negative. So you would need to put the negative inside the parentheses like this, But even then you might make a mistake and you might say, oops, and then you end up with a negative anyway. So I would just leave the negatives out of the calculation. So instead of saying b equals negative 3y, I would never let b equal a negative number. I will say b equals positive 3y, and then I'll just remember that every other sign is negative. The first one's positive, and every other one is negative. Do you guys understand that? Okay, let's see. Expand the binomial. Okay, so in a binomial expansion, we give numbers to each one of these terms. So this would be the n equals 1 term, and the n equals 2 terms, and the n equals 3 term, and so on. Well, I didn't double check to make sure they number it that way. Let me look really quickly. Zeroth row, first row, 1, 2, okay. All right, I was afraid of that. So, our Pascal's triangle 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. This row is the n equals 0 row. That's when the exponent is 0. A plus b raised to the 0 is 1. So this would be the n equals 1 row, and the n equals 2, n equals 3, and n equals 4. Okay, that's for the exponent. But as far as the position goes, this diagonal here is the n equals 0 diagonal. Okay, and this would be the n equals 1 diagonal, and the n equals 2 diagonal, and the n equals 3 diagonal. Now the cool thing about this is the n equals 1 diagonal is a linear function. If you graph those numbers, it would be a straight line. The n equals 2 is a quadratic. If you graph those, you'd have half of a parabola. And the n equals 3, those are x to the third graphs, and so on. So every once in a while, instead of doing the entire binomial expansion, you'll focus in on one term. So let's say that I had 4x minus 3 to the 12th. How long is that going to take me to figure out? A lot. So instead of figuring all of it out, let's just find the term when n equals 4. So we go to row 12, and it is 1, 12, help me out, 66, 220, 495, 792, and I'm going to stop. Okay? So what number is that? That's n equals 0. So this is the 0 term, the 1 term, the 2 term, the 3 term, and the 4 term. Okay? So all I want is this one. Can we do that one without doing all of the others? If we think a little bit, no. If I would have said n equals 5, then it would have been this one. So, and maybe that's a good idea. Let's do, it will give it to you. So if I said, instead of doing the entire polynomial, let's just do the 5th term, which is actually the 6th term, because you start with 0. So I want to know just that. Can we figure it out without doing everything? If we do a little bit of thinking, what's the exponent on a here? this would be 1 times a to the 12th times b to the 0. The next one would be 12 times a to the 11th b to the 1st. So we should just be able to count down. Excuse me. So this one is a to the 12th, 11, 10, 9, 8, 6. So 792 a to the 6th. Sorry, 12, 11, 10, 9, 8, 7. You're right. 7. Okay, and then what's b going to equal? It would be 0, 1, 2, 3, 4, 5. Do you notice anything interesting about those numbers? Seven and 5 add up to 12. Is that always going to be the case? Well, what would go here? It would be A, 8, and B, 4. Do those add up to 12? Yeah, it's always going to happen that way. Okay, so here you'll have 12 and 0. The next one you'll have 11 and 1. And then 10 and 2. And then 9 and 3. 8 and 4. 7 and 5. 6 and 6. 5 and 7. 4 and 8. They will always add up to 12. So that's kind of a little bit of a hint. Right. So if I was doing something to the 15th and I had a number times a to the 2nd, then it's going to be b to the 13th. Right. Okay. Another interesting thing is this number here is always equal to the b exponent. Do you guys see that? Some of you are writing down. Look up here for a minute. This number will always be equal to the b exponent. So we actually don't need to count at all. If I were doing 2x plus 1 to the 9th, and I wanted to know the 4th term, then I go to row 9, and I count over 0, 1, 2, 3, 4. What number do I get? 126. And then I'm going to have A something, B something. I already know the B. The B is 4. So the A would have to be 5. So this Pascal's triangle and the binomial theorem will save you a ton of time if you need to multiply large sets of binomials together. So we go back here. What do I do now that I have this? Plug in A and B. So 792 times 4x to the 7th times 3 to the 5th. So in my calculator, I will type in 792 times 4 to the 7th times 3 to the 5th, and I get, oh boy, big number. 315319910 what? X to the 7th. Do we have any y's? Nope. Am I done? Yes. I forgot something. I forgot to check for negatives. It's the 5th term. So if I go back here, positive, negative, positive, negative, positive, negative. Do I get a negative on my answer? Yes. Okay, and given the value of n to find the coefficient. So on 63 through 69, look at the instructions. it says, use the given value of n to find the coefficient of x to the n in the expansion of the binomial. And then it will give you the binomial, will give you the exponent, and then it will give you n. Okay? So it just wants you to find one term, but the instructions don't say find the term. They want the coefficient. So just this. What is the coefficient in front of the fifth term? And in this case, it's negative 315 billion. That was a really big number. Okay. So do you guys understand the pattern for binomial expansion? Okay. First step, go to the triangle, write down your coefficients. Next step, go through and write your a's and b's according to their exponent. Check for negatives. If if b is negative, then go through and make the first one positive and every other one negative. And then substitute your a and b in, and then do the exponents, and that will give you the polynomial. But on those last problems, all it wants you to do is find the number in front, so you can use those little tricks to isolate the nth term, and then plug everything in, and then you can drop the variables at the end. It doesn't want the variables, it just wants the coefficient. Okay? So you can finish your assignment, which we stopped at 41, so you need to do 43 through 71 odd. As combinations of numbers. What? I might throw out yeah, throw out 71. We're going to stop at 69. Throw out 71. Okay, good luck.